All right, example 3.9, we have a jet plane. We want to solve a problem involving an acceleration in two directions. I've doubled up my chart here so that I've got the x and y coordinate together. I've changed the delta x and delta y to be delta p. Maybe not the best notation, but for now, p stands for position. So delta p sub x would be this. So it's v naught x, v final x, etc. All right, we've got a jet plane traveling horizontally at 100 meters per second. So that is the v sub naught x of 100 meters per second. And it drops a rocket from a considerable height. The rocket immediately fires its engines, accelerating at 20 meters per second in the x direction. So that is going to be 20 meters per second squared, sorry. It is also falling under the influence of gravity in the y direction. So that is going to be negative 9.8 meters per second squared in the y direction. When the rocket has fallen 1,000 kilometers, that's a change in position of negative 1,000 meters. Find its velocity in the y direction. So part A, we want the velocity in the y direction of the rocket. Part B, the velocity in the x direction. B, the velocity in the x direction. And part C, find the magnitude and direction. The magnitude of v and theta of its velocity. All right, so with this problem, first of all, let's think about what we can solve for. Oh, think about other things we know. Do we know the initial y velocity? Yes, it's 0. We don't know the final y velocity. We don't know the final t. So let's find the final y velocity first, which is going to be based on the VAX equation, which says v final squared minus v initial squared equals 2a delta, and we'll change this to a y, or delta p sub y. Okay, and we'll plug in values of, we'll solve this for 0 because we know the v naught in the y direction is 0. So v final is square root of 2 times negative 9.8 times negative 1,000. And we should keep in mind that there's a plus or minus here when we take the square root. And it comes out to be 140. And the domain here is the negative numbers because this rocket is going to be falling. Now, how much time does that take? Well, let's get the time and then we'll solve for v final for the x direction. We'll use the delta v equals a delta t to solve for this. So delta t is delta v over a, which is negative 140 divided by negative 9.8, or 14.3 seconds. So that goes in for both of these, 14.3, 14.3. And we want to know how fast this guy is going after 14.3 seconds. So v final, I'll make a little space for it here. V final equals v sub naught plus acceleration times time, which is going to be v sub naught is 100 plus our acceleration of 20 meters per second squared times our time of 14.3 seconds. And the answer comes out to be 386 meters per second. So 386 meters per second. So we have our v sub y as negative 140 meters per second. We have our v sub x as 386 meters per second. And then to solve this, we need to take the square root. The total is the square root of 386 plus 140 squared. And then the angle will be theta equals arctangent of delta y, negative 140, divided by delta x, 386. And we won't add 180 because x is greater than 0. So it comes out to be 411 meters per second at 19.9 degrees below the horizontal.